Hello everyone, in this video we are trying to learn the rice mapping process using Sentinel 1 and 2 in Google Earth Engine. The codes are added from the paper, which is shared in the description. To briefly describe the process, so we will use the Sentinel 1 and 2 from the rice growing period in the monthly basis. We will have the monthly images of Sentinel 1 and the monthly images of Sentinel 2, which will be in the rice growing period, and we will use the clustering method, and we will get the different numbers of clusters, and we will observe the monthly charts of the cluster. So from the Sentinel 1 there will be this VH polarization, and from the Sentinel 2 we will have the NDVI, and we will select the clusters which will have some distinct curves or some distinct patterns that will be interpreted as the rice growing area, or that will be considered as the pixels where the rice must have grown. So overall this is the process, and this video will be helpful for all the learners, and this will be helpful for them who wants to know how the rice mapping is done, and will be helpful for anyone who wants to build the concepts related to the crop mapping. So we will jump to the codes and we will see line by line what's going on the code. So here the very first line is this one here. So this is just the selection of the area or our region of interest. So for this case I'm selecting somewhere from Nepal, and this is the district here, and I have filtered the specific area which is somewhere inside this district. So it can be any place, anywhere you like, but the particular selection of this area is that this has to be very small in order to make the codes smooth, because if the area is larger, so this might get some trouble, but in this case this area is okay for the demonstration, and we have added this as the layer here. And then we have the start date and end dates. So we can see here the start date is 2018, and the very first month of May, very first day of the May to the December of that year. So I'm selecting this months because this has to coincide with the rice growing period, and this will relate with the main season rice in this area. But there might be some other cropping patterns. For example, after the end of the main season rice, the other rice, the winter rice, may start in this area, and so this might cause some trouble during the rice mapping process. However, I'm selecting the months here from May to December. Then we have the Sentinel 2, and we see here this ee.image collection followed by these brackets and the strings. So this string is the unique code or the unique name for this Sentinel 2 dataset, and here we are filtering it with the start and end dates. So we can also use dot filter dates, but here some other ways is used, but it's the same. And then here we are doing this filtering of the metadata, and that is the cloudy pixels has to be less than some values, but I'm using the code as shared in the paper, so they have selected the 100, so we are not considering any of those strict values to be considered less than. So all the all the values that will have less than 100 will be considered. That should not have the greater than. And then we are doing this dot filter bounds, so all the images will be we have this overlap with this region of interest. So that's all. For up to this point, there's nothing. We have imported the study area, start and index, then we have this Sentinel-2 being filtered with dates and the metadata. And here we see dot limit 5 and then print. So this dot limit will help to when we select the first 5 data, we can change the values, of course. And here we want to see the first 5 values, and what it resolves is the very first 5 features or the first 5 images. And then we see this dot aggregate underscore array and then a spacecraft name. So this spacecraft name is the properties of that image, and it will just line or align all those spacecraft names as something like this as the list. So we have the Sentinel-2A and Sentinel-2B. So this will be helpful when we want to know what type of properties are there, or what type of things that property contains. For example, this might be helpful in the case of observing in the Sentinel-1 because sometimes the Sentinel-1B data might not be available. So that might be the case. Here we see the Sentinel-2A and Sentinel-2B resulted as the list. After that, we have this function add NDVI, and this function takes image, and then in this image we will add the bands, and the band will be the normalized difference, that is the NDVI. For that we are using this function dot normalized difference, and then here we are selecting the band 8 and band 4. We see the big brackets here covered by this brackets outside, and then we are renaming it as NDVI, and the result or the returned things or returned image will have this new band NDVI added to it. So this is the function here, and this function will add the NDVI. So the simple function here, but very important in the process of adding the new vegetation indices, and this can be done with any other vegetation indices as well. So here we see this has been mapped, and in the Earth engine this is the way to add or apply the function. So this dot map will add this new band. So dot map followed by the name of that function. And after that we just want to have the NDVI selected from all those image collection, and here we're doing this dot select, and we know the band name is NDVI, and this renaming is very important because sometimes by default the name is ND when we apply this function, and so we get confused if there is new band or not. So for this process, we need to have the renamed, so the new band has to be renamed. So we are selecting the NDVI, and now this will be assigned to the new variable named NDVI with all this capital. And again, we want to see if it really has happened or not, and we are printing them here, and we see in the features now there is only one band, and that is NDVI. And then we just want to do that monthly images or monthly NDVIs. So for that process, here we are assigning this value 1 to this variable named month, and then we are doing this difference between the end date and start date, and we want to know how many months are there. So we are doing this difference between the end date and start dates, dividing with the month and converting to the integer, and we are making the sequence from 0 to the total number of months. It might seem very different, but nothing is here. we are just finding the difference between the start and end dates here, and then we just want to know how many months are there from the start to end dates, so that we can have the monthly images. And here we see the process being done here. So this is the sequence, and we have also printed the sequence here. So we have total about 8 months, beginning from 0 to 7, and then that sequence, that number of months is being mapped with this function here by dot map followed by that function, and here is that number. This is our variable or the parameter in that function, and then our start interval will be like this. So we will have the start date. This will be advanced by the number multiplied by the month. So this will be the advanced, or the start date will have some advanced or some advanced done for those dates, and for the end interval we'll have the advanced by the addition of 1 unit. So these are the start and end intervals, and then we will have that filtered by the start and end dates. So we are filtering this NDVI with this start and end dates. So this will filter the NDVIs with some specific dates and the monthly basis, and then we will have the maximum values of all those pixels being selected, and then we will also have the time start properties attached to that. So here is this function. We are doing the start and end dates, or the start and end intervals. Then we will filter those NDVI images from the specific range, or the specific months for the month, and then we will have the maximum pixels from those NDVI, and we will also have the time start properties attached to it. So this dot set will have these time properties attached to that, and then we can print them. And so this image, this sequenced image, will be as the list. So this is actually not the image collection. So we can see here, this is the list, and for making it the image collection, we will have to do this ee.image collection from images. So this will convert the list into the image collection, and again, and to convert this image collection into the image with the number of bands, this is done by dot to bands, and we are clipping it for our area of interest, and then this will result this one here. So all the NDVIs will now be bands. So now we have the 8 NDVIs, 8 monthly NDVIs for our rice growing season, and this is now the image. And we can certainly rename those bands, and for that here the name is done like this: 105, 106. So this will be the band names. We can also have made the names as the name of the months, or anything that will be helpful for us. Here this has been done like this, and the renaming is easy. We just have this image followed by dot rename and the band names, and we repeat this process for Sentinel one as well. So we have this image collection, and for the Sentinel one we have this string Copernicus /s1_grd, and then again we are doing filtering of all the image properties. So the first one here is the VH. We are selecting the VH for the rice mapping process, and then we are selecting the VH. So Sentinel one has different instrument mode properties. IW is common in land, and we're also selecting the resolution meters as 10, And again, we are filtering it by the dates. We have the start date and end dates, and we are filtering it for our area of interest, and we can print them, and we can see something like this here. So we have about 78 features or 78 different images for our area in that time period. And we do the same thing for the Sentinel one as well. We advance with some units for the start dates, and we also advanced our indexes with some numbers. So each time this Sentinel one, our VS image collection will be filtered, and then we will do dot median in this case, and we will also add the time properties. So this is the same thing as done for the Sentinel 2, and we can print this sequence here, and again this will be something like this. So this is the list now. We convert this into the image collection, and again this image collection is converted to the image by dot to bands. So each image will be the new bands, and then we also rename the name of the bands as done for the Sentinel 2, and this is the Sentinel 1 thing. So we did the same thing for Sentinel 1 and same thing for Sentinel 2. What we detail now is we just had some filtering for the image collection based on the start and end dates, and then we also did some monthly images based on that. And now what we do is we just combine them by this here. We're combining the Sentinel 1 and Sentinel 2 by dot advance, because these two are now the images, and then we have now the 16 different bands. So half from the Sentinel 1 and half from the Sentinel 2. Now this is the stacked images. And now we begin the main process of clustering. So for the clustering we need some trainings. So this is the combined band, which contains the 16 different bands, half from Sentinel 1 and half from Sentinel 2, followed by dot sample here, and our region is our whole study area. Generally in the process of doing this, we consider our whole study area. This is for the unsupervised classification or the clustering method. For this region, we have this whole region selected for our training as well. And then we have the scale as 10. Then we have this number of pixels and tile scale. So this is generally used to make this process more efficient. We can change the values as we like, but it's okay in this process. And then here, this is the main function, ee.cluster.eekk means. And for this function, we just need to apply the number of clusters. So in this case, the value 30 is selected. So this will mean we will have 30 different clusters from those images. And the clustering will automatically assigns the selection of the values, and groups the clusters based on specific values. So it is just done automatically by this. And then we have this dot train. Our features will be the training. So this is our cluster, and we apply that cluster to the whole bands by dot cluster, and this then followed by the cluster. And then we rename the bands, we rename the name of that clustered. So this is renamed as we mapped. And now what we do is we want to see what types of the graphs or what type of the curves will each of that cluster will have. For that, we will add the bands. So this is our NDVI, and then this is being added to that list of to that NDVI images or that image collection, and then we have this combined NDVI cluster. So here we have the 9 different bands, and the last one is that cluster. Then we have these options just for the image charts. We have the title, the strings for the vertical and horizontal axes, and then there is this function ui.chart.image.byClass, and this function will just basically make the chart for each of that cluster. And this is the same thing also done for Sentinel-1. Here we are doing the same thing for Sentinel-1 as well, and we're adding them as the layer. So what we see is something like this. We have 2 different charts, and now the main thing starts here. So we will observe the charts here. This is the Sentinel-1 VH graph for each of that cluster, each of those particular cluster, beginning from 30 different clusters. Same thing for Sentinel-2 as well. So what we do is we will have our own guessing approach. For example, this cluster number 4 is very different compared to the rest of the group. It is not, I think it is not showing some graph, some curves in the process, and it is standing as something as very outlier. Similarly, for this one here, the cluster number 5 and the cluster number 11 seems to be somewhat linear, not going to the changes, and I will consider this cluster as the cluster which doesn't contain the rise. However, it is still very confusing, or still very challenging to just see which cluster is rise or which cluster is not rise. I will also observe the Sentinel-2, and we can definitely see this cluster number 4 is not among the like others. So this has to be the cluster which doesn't really contain rise. Same thing for 29, same thing for 5. So it depends upon the intuition, or it depends upon how we perceive or how we understand. So this will be generally depend on how we think what the rise curve, or what type of the spectra the cluster should have. But the basic idea was to observe the curves of 30 different clusters. So we're seeing from 0 to the 29th cluster, meaning 30 different clusters, and we will just observe and think and rethink if that cluster is rise or not. So after doing this, what we do now is, so we have the values here beginning from 1 to 30 for 30 different clusters, and what we do now is, as I thought, this value 4 is definitely not the rise cluster, so I will assign this value as 0 here. And similarly, this 5 does not seem to be rise at all, so this will be also done as 0. So this is just reassigning the values. So any cluster that is that seems to be rise will be assigned as 1, and anything that does not seem to be rise will be assigned as 0. And what we do here is the same thing. So we will have this function .remap. So our value 0 is by default, and this will have the new values assigned to that of the 1 and 0 values. So 1 will be the rise and 0 will be the non-rise. and that we mapped clusters will update it by itself, so just to show the values that has 1. And then we have also this other thing, so each time what we do is we will just basically rename those 1 values into some distinct number of groups, beginning 1, 2, 3, 4, 5, 6. This is just the remapping of those values that contain 1. And we have these 17 different clusters that is believed to be the rice. And we are doing the same process here. We are remapping the values from values 0 to values 2, and we will update this by this new clustered. And what we see here is all the addition of the different layers, and here this dot random visualizer gives the number of different types of colors. And I also happen to have this this rice map developed from the Modis just to compare if this has really captured the rice pixels or not. So we will see here. So the first one is the study area. So the second one, I think this is the second one. This is the NDVI. Then we have the edge, and here we have the clustering. So these are the 30 different clusters. Then we have this one here. This is the rice here. So this is the rice map, or this is supposed to be the rice growing areas if this whole thing is correct. And this is the values assigned from number 1 to 17. So we have 17 different types of rice growing pixels. So these 17 different clusters were supposed to be the rice growing area. So we assigned the new values to each of that rice growing clusters. And I happen to have this this Modis-based rice maps, and you can see it is not exactly very appropriate to say or to compare, because this Modis is somewhat very different. And here we are doing it from the Sentinel 1 and 2 in 10-meter resolution. However, in some areas like here, this has been captured pretty nicely. And if we also zoomed in very closely, for example, and this is the satellite layer in the background, and you can see that in this area, for example, this has not captured or included these rivers. And if we zoom in somewhere like this, and in the very close inspection, for example, the resulting rice map has not included these trees or these tree growing areas. We can definitely see this has not included some tree growing areas. But we're comparing this with some high resolution image. So, however, I think this has kind of captured the rice growing areas. So basically, this is it. To summarize again, let me summarize again. If what we did was we just had this 2 different images from monthly images, 2 different monthly images from Sentinel 1 and 2, and we clustered the images. We observed the monthly charts of each cluster. We observed the NDVI chart. We observed the VH polarization charts. And then we just assigned the values. If the clusters were supposed to have rice, we assigned the values as 1. Otherwise, the values were assigned as 0. And this kind of helped to observe the rice growing areas. So overall, this is the approach of doing this in the unsupervised classification. Of course, there are different things that should have been considered. We could have used some other vegetation indices as well. We can certainly try this with AVI. We can also have other approaches using multiple vegetation indices, and we could also be more sure if we are more certain about the rice growing months. For example, the selection of this might not be that appropriate because this area has some other types of rice growing on as well. For example, there is this winter rice going on after the November or December, I don't know. However, the overall approach is like this, so I hope this was helpful for you. If you have any questions, please comment. We will have our discussions. Thank you for watching.